Hello everyone, welcome to Practical Mechanics. Today's video is about the statically indeterminate problem. Problems that you cannot solve them by equations of equilibrium only. You need to consider strengths of material or mechanics of material formula as well. In this problem, we have three steps. The first step, write the equations of equilibrium. Second step, write relation between force and deformation. And the third step is to find out a geometric compatibility for the problem. Let's start with an example. If we have a tube, steel tube, that's a steel, modulus of elasticity 30, 10 to power, for example, 6 psi, construction steel. And we fill it with concrete. We fill it with concrete. And I show it here in 2D that the tube or pipe has a column filled with concrete, and this is a rigid plate. And here we have a concrete. With modulus of elasticity, EC, and here ES. The length for both is L. Cross sections here is A steel, and here is A concrete, in order. If a force applied on the top, force P, to the rigid plate, we use the word rigid here because we don't want this plate deform and stay the same before loading and after loading. This rigid plate is staying perfect flat, no deformation. Then, when force applied, a portion of this force is taken by the steel tube, and a portion, a percent, is taken by the concrete. They are not equal. We wanted to find out how much force is taken by concrete, how much is taken by steel. In this case, you can write equations of equilibrium for this plate. One force P concrete and another force which is rounded, we called it in total F steel. Is not 2F steel because it is a ring, and the total we show it by F steel. And this is the total load P. Equations of equilibrium says that P minus plus F steel total plus P concrete, or it's better to call it F concrete, is equal 0, where we take it from summation of forces in y direction is equal to 0. Equations of equilibrium in static. We don't have other equations. We don't need other equations here. Just this one apply. Then it means that F steel total plus F concrete total equals to P. Okay, we have one equations here. This is equations of equilibrium. One equation, two unknowns. We cannot solve it. This is why they called it statically indeterminate. Then let's go and find the relationship between force, applied force to a steel, applied force to concrete, and deformation. The force applied and we have a deformation. How much? Delta steel is equal to F steel, L steel, A steel, E steel. And delta concrete is equal to F concrete, L concrete, A concrete, E concrete. That's the force deformation relationship. What else? Third step, this is the second step. Third step is to find a geometric compatibility. Geometric compatibility says that these two materials has the same deformation because they come down together. They cannot be separated from each other. What does it mean? It means that delta steel is equal to delta concrete. That's the third step. Third step here, geometric compatibility means the deformation in both are the same. Then we use these equations, geometric compatibility, then these two values are equal, means that F steel, L steel, E steel, A steel, FC, LC, EC, AC are equal. Then we can reach to another equations that Fs, we can find F steel equals to, we only know that length in both is the same. L steel and L steel are equal. You can cancel these two out. This is L. L steel, LC, they are equal to L, and you can cancel them out. But you have values of ES, EC, AS, AC, but you can write here that ES divided by ECAC times FC. This is the relation that you can find. And they had another relation that Fs plus Fc equals P. You can find this system of equations. And for example, substitute here. Instead of Fs here, you can write ESD, ASD, E concrete, A concrete, PFC plus FC equals P. And you can find it how much is FC, what portion of P is FC, and then you can put it in here. If you find FC, you can find it here, what portion, or you can subtract it as a percentage, 100 or 1, find the portion of the force that is exerted, or subtract it from P. When you find FC here, subtract it from P and find Fs. And there are many problems in mechanics of material that are statically indeterminate, and you have to use mechanics of material formula and geometric compatibility to solve them. Later in another video, we solve several examples for you. Thank you for watching. See you in the next video.